Welcome back, and today we are going to see Matplotlib library. In this library we will see how to plot different graphs. We will see line plotting, different type of bar graphs, histogram, scatter plot, pie chart. We will see all these type of plots. So guys, can you please confirm me, am I audible, clear and loud, so that we can go ahead? Hello. So we will see how to install the Matplotlib, and then we will create different type of plot. Now I will tell you the simple plot. Okay. Okay guys. So first of all we will plot the simple plot, and we will install Matplotlib. How to install the Matplotlib? Pip install Matplotlib. Okay, so pip install Matplotlib. This is the simple command you can use to plotting different graphs using the Matplotlib. Okay. You can run this command, and if Matplotlib is already installed, it will tell you requirement already satisfied. Otherwise, if you are using any ID, other ID like Jupyter Notebook and PyCharm, you need to install the Matplotlib. Google Colab having already installed Matplotlib. So from Matplotlib, import pyplot as PLT. We need to use pyplot package from Matplotlib. Okay, so from Matplotlib, import pyplot as PLT, and then you can see we need to write one function from pyplot is plot. So plt.plot 1, 1, 2, 3, inside one array I'm passing x-axis, and inside second array I'm passing coordinates for the y-axis. So here you can see x1 is 1 and y1 is 4, x2 is 2 and y2 is 5, and x3 is 3 and y3 is 1. So these are the 3 points we are plotting. So here you can see first point is 1, 4, second point is 2, 5, and third point is 3, 1. Okay, and if I run this code, it will show you a line plot. So simple plot function will give you a line. Okay, so this is the Matplotlib library, a simple example I have shown you. So why we use the Matplotlib? Basically, visualization gives you better idea when you are using certain data, like you are creating some algorithm for the machine learning. So you just want to see the results in the form of plots. So you can create different type of plots of your results. Okay. Okay. Guys, clear? Now come to the GoEdu Hub, and then you can see the reference notes available here, free tutorials, and inside the free tutorials you can go to the machine learning, and inside the machine learning you can see the Matplotlib library. Okay, and this Matplotlib library is having documentation that I'm referring, like we are going to generate different type of plots like histograms, power spectra, bar charts, error charts, scatter plots, etc. We will create these type of plots within few line of codes. Okay. Clear guys, everything till now? We can go ahead. So this is the simple plot I have seen. We are going to see lots of plots. We are going to create different type of plots, and we will see how to write the X's, title, X label, Y label, and then we will see how you can create different type of grids and legends. All these things we are going to create now. Okay, so second type of plot, I'll create this simple, in this simple plot, I will provide certain x-axis, y-axis, and then I'll provide title also, okay. So plt dot title, and here I'm writing some information. Okay, title I'm providing information. Now I can run this code and you can see what does mean this title. This title function will give you here the information. Okay, and then I'll provide X label and Y label. Like over the X axis I just want to write some X label, and over the Y axis I just want to write some Y label. So plt dot X label, I will write x-axis. Okay, and similarly I'll use another function Y label. Okay, and here you can see over the x-axis we are having x-axis written, and over the y-axis we are having y-axis written, and at the top of you can see the title information. Okay, so we are going to see different type of plots: plt.title information, plt.xlabel x-axis, plt.ylabel y-axis. Okay, now I'll give different type of lines. Like I just want to create different color for the line. I just want to give the different style to the lines, like dotted line, and I just want to put the red color line, green color line, and multiple plots into a single graph. Okay, so for this what I can do, I can write here some x points. So I'm writing here x points like 15, 18 and 20. Okay, similarly I'll put some y points 22 and 26 and 16. I'm taking random numbers, and similarly I'll take some more points. I just want to draw two lines. So x2 like 6, 9, 11. Okay, and then I'll put y2 equals to 6, 15, 7. Okay, and now I'll plot a single line like plt dot plot. You can see what I can write here: x, y. Okay, and some more parameters I can provide here. Like I can give the color. So here, third parameter I'm providing, I just want the red color. Inside the single quotes I'm providing R. I can give the label also. Okay, And here I'll just put the label also. Label is like this. Label equals to line. I'll put the some label. So label equals to, inside the single quotes, I'm putting line. Okay, and I can give line width also. Line width equals to 5. Okay. Similarly, I'll put another line. plt.plot, and inside this I'm putting x2 comma y2. Okay, and then in place of red I'm putting here the green color. Okay, and label here I'm putting label equals to, inside the single quotes I'm putting line 2. Okay, in first one I'll put line 1. Okay, and line width I can give anything, line width equals to 8. Now I'll run this. You can see one line is red and one line is green, and plt.show. This function is removing this line, matplotlib line. This description will be removed when I write this line plt.show. You can see thickness of the line also, like red line having less thickness and this green line having more thickness. Okay, red line and then green line. Now this title label I have put it, but it's not showing the label. I just want to show this label here, like red line represents line 1 and green line represents line 2. Okay, so label I need to put here. How to put the label? For putting this label, I need to write one function called legend, plt.legend. Okay, when I call this legend function, you can see the output. Legend. Legend is showing this red line represents line 1. We have provided label, whatever the labels we are provided inside this plt.plot function, these labels will be visible only after you are calling legend function. Okay, by default these legends are put it into this left side, left top corner, and you can set its location also. Okay, and similar thing I can write like plt.title. Title I can put some information, graph, and then plt.x label and y label I can put. X label I can put x-axis, x-axis and y-axis. Okay, x label and y label is put it here. Title is graph legend plt.show. Okay, you can also enable the grid here, like I can write the one function plt.grid, and inside this I'm not putting any parameter, by default it will enable grid. I can give the color of the grid, like red color, some other color. I can give the color for the grid. So here you can see grid is enabled. Okay, we have created two different lines. And we have put it certain parameters like this, label and title, x-axis, y-axis, all these things. And then you can say the line width, you can see the color for the lines, all these things we can set. Okay, now I'm moving towards the some other type of graphs, like let's see, we will understand the bar graph. Okay, so this is the simple line graph we have seen. Now we will plot a bar graph. Okay, first of all, what is the bar graph? Okay, why do we need a bar graph? Generally, bar graph uses bars to compare the data among different categories. Like you are having two categories and you just want to compare the data. Like you are watching cricket match, and in the cricket match you are seeing different type of graphs. They are showing like run rate and all these things. They are creating bar graph, pie chart, and you will understand how much balls are giving how many runs. All these things we can compare. So when we want to measure the changes over a period of time, okay, we can create the horizontal and vertical bars. Like we will create one bar graph. Let's implement it. Okay. Okay, so here plt.bar plot we are having, function for the bar we are having is bar function, and here we need to put x-axis and y-axis. Okay, so we will see let me come to here. First of all, I'll show you one graph. Okay, here is a bar graph, and this bar graph having first thing is x-axis, okay, and second thing is y-axis, x comma y. Always we need two parameters for plotting any graph, x and y. So x coordinates, list of x coordinates, and list of y coordinates. Okay, and label, color, all these things are optional. Similarly, second bar graph here we are having, and output you can see here. This is the output. In this output, what we are measuring? Basically, we have shown the comparison between the distance covered by two different cars, BMW or Audi, over a period of 5 days. Here in the x-axis we are having days, and in the y-axis we are having distance. Okay, so how much a car, like red bars represents BMW. So BMW car traverses how much distance in 3.25 day? It traverses 80 kilometers. And same BMW Audi travels 20 kilometers. So we are doing the comparison of distance covered by two different cars. When you want to do some comparison type of things into different entities, then you can use the bar graph. Okay, so let me put here like you can see data I'm picking from directly from the website. So plt.bar 0.25 and corresponding to 0.25 y-axis is 50 and x-axis is 1.25 means day is 1.25 and distance is 40 kilometer. Day is 2.25 and distance is 70 kilometer. Okay, and label we are putting like BMW car is color is red and width is 0.1. You can change these things. Similarly, second bar graph is we are putting for the Audi here x-axis 0.75, 1.75, 2.75 and 3.75. And you can see it's a distance covered. And this label will be enabled only if you put plt.legend. And then X labels and Y labels you already know, title you know, and after that we have put it plt.show. Now I can run this code and you can see the output. Okay. So in this plot, what I have done, comparison between the distance covered by the two cars, BMW and Audi over a period of 5 days. Got it? Bar graph? You can put the 3 cars also. I have put it the 2 cars. You can create one more bar graph. Like third car you can pick and you can put here x-axis and y-axis. I just want to show you the comparison between different data. Okay. So I think you got the concept of bar graph. Now we will move towards the another type of graph that is called the histogram. Okay. So first of all, I'll tell you what is the difference between the histogram and bar graph. Why we need the histogram. Histogram basically show you the distribution among the data. Like in this class, we are having different students. I just want to see the distribution, how many students are like from 4th year, BTech 4th year, how many students are from BTech 3rd year, how many students are from BTech 2nd year, and how many students from BTech 1st year and some other category. So basically, I just want to see the distribution of the data. It is basically useful when you are having a long list of data and you just want to plot the data. Like I just want to see the distribution of my students in this class. Here we are having 2 things. One is bin. Bin refers to the range of value. Like what we are taking a interval. I can take the another example for the age. Like I'm having different age groups. Okay. I'll put the students into 4 groups. Like one is 15 to 20. Okay. And then 20 to 25. And then I can put the 25 to 30. Something like this. I can create a range of value that is divided into a series of intervals, you can say. And generally we are creating bins of same size. Like first bins we are created from 15 to 20, so next would be 20 to 25, 25 to 30, something like this. Okay, so the difference between the bar graph and histogram is, bar graph is generally used for the comparing different entities. And histogram is used to show the distribution among the data, whichever the data you are having, you just want to see the distribution. Let me tell you one example, like we are taking example of age. We are having population, so you can create a list of age. And inside this list, I'm putting certain values. Like some people having 18, 19, 20, and then I'm repeating again 18, 18, 20, 20, and then 25, 24, 23, 22, 24, 18, 18. Some random values I'm picking here. $30, $25, $30. Okay, I have taken a big list, and in this list I'm having certain ages of the students. Okay, now let me write the beans. I just want to create the beans. Okay, so beans I can put here beans of 5. So first 0, then 5, 10, 15, 20, 25, 30, 35. Now I'll create a histogram plt.hist. Okay, and inside this I need to put age and beans, age comma beans. Okay, and I can give the some more parameters like his type. His type I'm providing here bar. Okay, and that's all. And then I'm writing here plt dot show. And you can see the graph. I can take some range of 5, age 5, 6, 5, something like this. Let me run this again. Now you can see students in the range of 15 to 20 is maximum 14. Okay, you can count from your data also, like how many times 18 is repeated. You can count manually also. Here what we have done, we got the age groups with respect to the beans. Our biggest age group is between 15 to 20. So you can see this is a distribution. And in this hist type, you can put some more different parameters also. Hist type, I don't remember what the other values we can give. Hist type value, step also we can give. Yeah, step. Step is like this. Okay, you can see the documentation for the Matplotlib. This is Matplotlib documentation. User guide you can see, or tutorial you can see. Okay, and there are some examples available, like bar graph demo you can see, and histogram I'm not able to see, but there would be histogram also. Yes, histograms. Okay, how to plot the histograms. Got it? So we have plotted one histogram. In description of this video, we have put reference notes also. So you guys can see the reference notes is available in description of this video. Okay, so this is the histogram. Now I'm moving towards the another type of graph, scatter plot. Okay, what is the scatter plot? Let me write here. Scatter plot. Okay, scatter plot is generally used to compare the variables, like how much one variable is affecting to the another variable to build a relation. Like basically what we are having a collection of variables, and each variable having certain values like x and y coordinate, and that x and y coordinate determines its position on horizontal axis. X and y, one is determines its position on horizontal axis and one is determines its position on vertical axis. So scatter plot is basically we are plotting certain points and then we are comparing the points. Okay? So let me write here x equals to some values like 2, 2.5, and I can say 3, 3.5, 4, 4.5, and 5. And similarly, I'll put some values for the y-axis also, like 8, 8.5, 9, 9.5, 10, 10.1, something like this. How much values? 1, 2, 3, 4, 5, 6, 7. So here also 6, and I need to put one more value, 10.2. Okay. Now I can plot a scatter plot. For plotting the scatter plot, we are having a function called the scatter. plt.scatter, and inside this I can put x and y. Okay, and then I'll write plt.plot, and let me run this code. Points are plotted. Certain points are plotted. Now I can give the x label, y label, title, legend, all these things I can put here, label. So here I'm providing color red, okay, and I'm providing label equals to line 1. Okay, and I'll put plt.xlabel. Inside the x label, I'm putting something income, and inside the y label, I'm putting saving. And then plt.title. This is scatter plot. And now you can see color is red. And I need to put legend also. plt.legend. So legend is line 1. I can plot more lines also. Like I can put the certain other points x1, x2, x1 and y1. Okay. Inside the x1, I'm putting some values like this: 8, 9, 8.2, 8.3, and then 8.6 and 9. And similarly, y1 equals to something like this: 3, 3.1, 3.4, and 3.8, and 4.2. And let me write another scatter plot: plt dot scatter x1 comma y1, and then color equals to green, and label I can put line 2. Okay, and now you can see this red one is line 1 and green one is line 2. So I have created 2 lines. Okay, I have plotted 2 scatter plots based on the input which I have provided. So basically data is displayed as a collection of points. You can compare like the people who having high income and less saving, and here you can see people who having less income, high saving. So this is the scatter plot. Okay guys, getting the things? Can you please confirm me in the chat window everything is clear till now? Like what we have seen simple line plot, and then we have seen bar graph, we have seen histogram, and now we have seen scatter plot. plt.plot is basically plotting the lines. There is different functions. One function I have used, let me write here text. One function I have used, plt.plot. This function just for creating lines. Okay, then I have used plt.bar. This function is for creating bars, bar graph. Then I have used one function plt.hist. This function is used for creating histograms. Okay, and then I have used plt.scatter. This function is used for creating scatter plots. These different functions I have used. Yeah, other things are same, these functions are different, and in these functions what we need to pass? We need to pass x and y, and then other decoration part you can do like x label, y label, legends, and you can write the information like title and colors, width, thickness, all these things you can give. Yes, we will come to the 3D also, but first we understand these simple plots. Yeah, dot connecting line I'll also tell you. Okay, how to connect these dots. Okay, and let me write another code. Like I'm going to plot certain lines, but dotted line, dot connected line, I just want to plot a dot connected line. So here what I'm going to use, I'm going to use numpy also. Import numpy is np2 creating an array. Okay, and here I'm plotting a line plt.plot, and inside this I'm passing simple values 1, 2, 3, 4. And then I'm passing y-axis values 1, 4, 9, 16. It's a square. Okay, and then I'm passing, like I want a line in which point should be like round. Okay, so I want a red color line, or color is red, and the shape of the points I want O shape. Okay, and here I'm putting label equals to line 1. Okay, and now I'll plot this graph like plt dot plot, plt dot show. Let me run this. Here I have put it only dot is red dotted. Now I just want to connect these red dotted. Okay, to connecting red dotted, I just want to give one more parameter, dash. Let me run now, and you can see red connected dotted. Okay, I have created points red, and point shape is O. Okay, and this dash represents it will connect the points. Okay, like if I'll write same thing, let me create one more. I'll create multiple lines in a single plot, so you will got the more idea. Okay, 1 2 3 4, and then here also I'm putting 2 3 and 4. Okay, and then you can see here I'm not putting this, I'm removing this part, red and O. Okay, I'm simply putting line 2, and here in place of this I'm putting green, and I'm removing this dash, and line 3, and here I'll put plt.legend. Let me run this code. Okay, points are same. I changed the points. Okay, so this first one is, you got it, line 1. Line 1 represents red points and dash. Line 2, here I have not put it anything, so simply it will create a line to joining these points, and points are not pointed out, simply it will create a blue line. And in the third one I have put it only G and O, means color and point shape, so it will create just like a scatter plot. Okay, and this is called the marker. These points are called the marker. I can create the shape of the marker, I can create the marker face color, different type of shape and face color I can give. Here like in place of O, I can put a star also. So points would be like star. Okay, these 3 lines I have created, line 1, line 2 and line 3. There are the lots of properties are available. You can plot the different plots in a single plot, like let me plot one more thing, like I'm creating T equals to np.arange, okay, and a numpy array 0 to 5, and difference I'm taking 0.2. Okay, and then what I need to do here, I'm creating a plot between T to T. Okay, so plt dot plot T comma T. This is the simple plot. And third thing I can give here, like shape and color. So red and dash dash. Let me run now. This dash dash line. Okay, and I can create multiple line here in a single plot. Okay, fourth parameter I can give t comma t to power 2. Another line. This is one line, and now I am creating another line. A graph between t and t square. Okay, and for this graph I'm providing color is blue and shape I'm providing O. Let me run this. This is the second plot. Plot between t and t square. In a single line I can create multiple plots. Yes, we will see these plots. We are going to create these plots in the machine learning algorithms. That's why I'm telling you now, like Monday onwards, we will start the machine learning regression algorithm. Simple algorithm for the machine learning. First algorithm we are going to cover is regression. So in that, what we are going to use? We are going to use NumPy, Pandas, Matplotlib, and then machine learning library scikit-learn. So all three libraries like NumPy, Pandas, Matplotlib, you already know. So when we are going to do an example of machine learning algorithm, it would you will feel like you are knowing most of the things. Okay. In a single line, you have created multiple plots and plt.show. This np.arange function we already seen in the NumPy. This create an array between 0 to 5 in the gap of 0.2. Like it will generate the points like 0 and then 0.2, 0.4, something like this. Okay. Scatter plot we have seen. Now we can see area plot, pie chart, and we can work with the multiple plots also. And you can see the subplots. Yeah, somebody is asking for area 3D plot. I'll cover 3D plot. Just wait, first we know the 2D plots. I'll show you one 3D plot also with the help of this Matplotlib library. Generally for the 3D plots we are using Seaborn. Matplot is we are using just for 2D plots only. Okay, but still I can show you 3D plot with the help of Matplotlib also. Like I need to put certain values. Some file I'll download, iris.csv. I need to log into the Kaggle. Okay. Let me download this iris.csv dataset and I'll show you some 3D plot over this data. Okay. You can download the iris.csv dataset and I'll show you one 3D plot using this dataset in the Matplotlib. Okay. Import pandas spd. We need to read this file and then import numpy as np, and matplotlib we already imported. From matplotlib import pyplot as plt. Okay, these are the things we are going to use, and then we will see. We read this data, iris. I need to upload the data file here. Iris.csv. Okay, and then iris equals to pd.read underscore csv function I'm going to use, that is the pandas function, and here I'll put the name of the file iris.csv. Okay, and then I can print what is inside the iris. File not found. Let me check it out. I capital. I should be capital here. Name should be same. Okay, yeah. This is the file, and this file having different parameters like sepal length, petal length, sepal width, and petal width, and species. So we are having different species. Okay. In this data set, we are having 3 species. One is setosa and versicolor and virginica. So these 3 flower species, and we are having their features sepal length, sepal width, petal length, and petal width. This is data set of these flowers. Okay. So now I am going to create a 3D plot. First I'll create a 2D plot and then I'll create a 3D plot. 2D plot I can create between 2 parameters, like either I can take the sepal length, sepal width, or petal length, petal width, any of 2 from these 4 parameters, and corresponding species. Okay, so let me write here 4 species. Okay, and then what I need to pick? Species and iris subset. Iris subset, I'm taking a 2 variables. In iris data I will group by, okay, group by column name. I need to check out this column name is species. I need to check out the data, like inside this data what type of columns we are having. Okay, so I'll pick this species and I'll group on the basis of species. Okay, and then I'll create a scatter plot, plt.scatter, and here I need to pass petal length and petal width, 2 parameters. Okay. So iris subset, it will give you 2 things. Iris subset and inside the iris subset I need to put the column name. So petal length, let me pick the column name, this. Okay, and similar thing I'll do for the iris subset, and then inside the braces I need to put another column, petal width. Okay, X and Y, and label here I'll provide species. Okay, label is species. Let me plot this, plt.show. Let me check it out. Yes, you can see here this data set having 3 species. So I have grouped by species. Okay, and then I'm getting 2 things. First is species name and this data set. So all these other columns. From these columns I just want 2 columns, petal length and petal width. So this is my x-axis and this is my y-axis. And labels I have put it here species. I can put here legend also, like plt.legend. plt.legend. Let me run this. You can see legend. This is one category, blue one, and this orange one is another category, and green one is another category. Okay? Okay guys, getting the things? Clear guys? I have taken a data set, and from this data set I have simply created a scatter plot. So like this we are going to create the certain plots in our machine learning algorithms. Like when we are going to use this data set, iris data set, and we train our model, that model will predict which category, which species output would be. So we can plot the data like this. Iris.csv is a data set. I have downloaded a data set, iris.csv. You can download from the Kaggle, and then I have read this file with the help of pandas, read_csv. So I used here pandas as well as Matplotlib. And I can write other things like X label, Y label, that you can do easily. Okay, now I can create the 3D plot also for this. For the 3D plot, what I can do, like here I am limited to take only 2 parameters. Now I can take the 3rd parameter also in the 3D. Okay, so for creating the 3D plots, what I can do, let me write here. Okay, I can create a figure plt.figure. Okay, this is just creating a figure, and this figure I am doing 3D projection. So I am writing here xs equals to fiz dot, I need to import one package, add subplots projection 3D. Like for the 3D I need to import one toolkit, I think. Okay, let me write here, or otherwise if it will throw error, I'll import that. There is a function called add underscore, I think subplot, I don't remember, and then I can write subplot, you don't know, projection, I'll explain you this also, projection equals to 3D. Okay, this is simple for the figure I'm writing here. Now the thing is, here the line which I have put it, I'm copying this thing and I'll add one more parameter. Let me copy. Okay, and here I'll put one more parameter, like in place of plt I'll put here ax. Okay, ax dot scatter, and then petal length, petal width, and I'll also take sepal length. So one more parameter I need to put here, Control V, and sepal length. Let me copy the column name. Okay, I'm providing 3 parameters. Okay, and then I need to put here, some things like ax dot labels. I can set x-axis, y-axis and z-axis. So set underscore x label. Okay, x label is what? Petal length. Okay, and similarly x dot set y label, petal width, and then you can see x dot set underscore z label. Sepal width. What I have taken, I don't remember. Sepal width. Let me run this. Yes, I think I need to import one 3D package toolkit from Matplotlib underscore toolkit. Mplot 3D, something like this. Import axis 3D. What? plt.scatter, syntax, invalid syntax. Okay, comma is missing. Yes, this is the 3D plot. I think without toolkit it also do. I don't remember. Let me remove this. Yes. You don't need to put the toolkit. By default it will take from here. Projection is 3D. You can remove this. You can see here we have put it 3 parameters. This is 3D plot. Somebody was asking for 3D plot. Okay? Yeah, without package it's working. There was the error for the comma. Like I forgotten to put one comma. Okay? So like this we can put the 3D plots. Okay, so this is the simple part you can do, and now I'll tell you some remaining plots because we are having very less time, so I'm going to cover remaining plots. I can tell you these from here only. Area plot, it is very less important. We are not using as much the area plot, and area plot is similar to the line plot. They are also known as stack plot. They can be used to track the changes over the time for two and more related groups. You can see here we have plotted an area plot like activity for a person in a day. So what a person is doing in a day, like it's doing eating, sleeping, reading, playing, all these activities. So these activities divided into different parts. It is simple to line plot, but it's a stacked plot. So here to creating the stack plot, we are having a function plt.stackplot. We are taking days and corresponding to days we are plotting different activities like sleeping, eating, working, playing. And for these activity we have created different labels like different colors and labels. Label is sleeping. For the sleeping we have put it the color M. M is I think for maroon, okay, and color is M, label sleeping, and line width is 5. plt.plot. Inside the plot we are not putting anything. This is just for the legend, creating the legend. Okay, so we are putting different labels and color combination. And when you are creating a stack plot, you are putting days and these activity name. What is the activities having? A activity having, like here x-axis having days. So we are having 5 days. 1, 2, 3, 4, 5. And for 5 days, what in the first day sleeping is 7 hours. In the first day sleeping is 7 hours, eating is 2 hours, and working is 7 hours, and playing is 8 hours. Similarly, in the second day you can see sleeping is 8 hours, eating is 3 hours, and working is 8 hours, and then playing is 5 hours. So everyday activity, it's a 24 hours for a day, or activity 24 hours is divided into 4 activities. Okay, so you can create a stack plot like this. Other things are same. And next thing is pie chart. Pie chart is how to create the pie chart. Pie chart is like this. In the pie chart, we are dividing in 360 degree. Like you are having 4 activities and you need to show these activities in the form of a pie chart. Pie chart is basically, you can say, a circular graph which is broken down into different segments. Here you can see we are having 4 segments, or you can also call them slices of pie. It is basically used to show the percentage, or you can say proportional data, where each slice of pie represents a category, like working category, eating category, sleeping category, and playing category. So what we can do for this, we can have different activities. Okay, so here we are having 4 activities. And these 4 activities we have divided into 4 slices. Okay, 4 slices like 2, 2, 2, 13. So you can do the total. 6 plus 13 is 19, and 19 you have to divide into 360 degree. So 2 divided by 19, first part, 2 divided by 19, second part, and 2 divided by 19, third part, and 13 divided by 19 is fourth part. Means out of 19, two part is for sleeping, 2 part is for eating. So these 3 activity having equal shape. So you can say this is 360 and 360 is divided into 4 parts, and maximum part, who is having maximum part? Playing is having maximum part is 13. So area, total 13 area we have provided to the playing, and remaining part we have divided into 3, 2, 2, 2. It automatically create. What function we need to use? We need to use the pi function, and inside the pi we need to pass the slices. So here 4 slices, we have provided the 4 slices. So it will automatically divide 360 degree into 4 slices. And labels, you can give the activities. Here labels we have provided, and then you can say the start angle at 180 degree it will start. Like first activity will start from 180 degree. Then it will go like this. Shall I create this pie chart? Let me go here. I'll explain more clearly. You can say we don't need these days. We need only slices, and I'm running this code. Slices, you can say, I can change the value of the slices. Like here, in place of 2, I'll put 12, 2, 2, and this is I'll put 30, something like this. Now you can see the difference. One part having 30, so it will do the total 12 plus 2 plus 2 plus 30, and then it will divide the total 46 into 4 part in ratio to 360 degree. So this is the pie chart. Okay guys, clear till now what is the pie chart and how to create the pie chart? Now one more remaining part is working with the multiple plots. Multiple plot is simple. For the multiple plots, start angle is 180 degree. 180 degree, like in place of this 180 degree, I can put 90 degree. You will get the clear idea. Change the parameters always. 90 degrees, it will start, first activity will start from 90 degree. Okay? At 90 degree, first activity sleeping, then eating, then working, and then playing. Anti-clockwise. It will start from 90 degree and will go anti-clockwise. We need to start from somewhere in the pie chart. Okay, one small part in the Matplotlib is remaining, that is the subplots. So I'll conclude with the subplots. Okay, subplots is also simple. In the subplots, we can create multiple plots. Let me copy this code. I don't want to write the code. I'll explain you the things very easily. Because code is available, you guys can write the code. It will take too much time. Okay? So here what we are doing, just understand line by line. We have imported numpy matplotlib. Then I have created one function def f of t. And inside this f of t, we will return an expression. What is this expression? E to power minus t into cos 2 pi t. This is simple numpy expression. Okay, mathematical expression we are solving with the help of numpy. So when we are passing t value, okay, when we are calling this function, when we are passing t value, this will return you this expression value. So here t1 we have generated with the help of a range function 0 to 5 and difference is 0.1. It will create an array between 0 to 5 and values in difference of 0.1. Similarly, t2 also generate an array with the help of numpy a range function. Now we will create a plot between t and f of t. T is this t1 we are having an array. You can print the t1 and if past this t1 we will calling f of t. So f of t, t versus f of t and t2 versus f of t. We are creating two plots. Okay, but here we are using one function called subplot. What do you mean subplot? Subplot is creating multiple plots. And how we are creating the multiple plots, you can see here. Like we can creating multiple plots vertically and we can creating multiple plots horizontally also. Like here we are passing three parameters. It means we want to create this 2 represents number of plots. How many plots you want to create? I want to create 2 plots. You want to create row wise or column wise. Here I passed 1. Now I am passing 2. 1 means row wise and 2 means column wise. And this third parameter represents first plot. So this is the first plot. I'll remove this also. Confusion. Okay, simple plot. I'm creating a plot. Okay, and let me remove this also. A simple plot. Here I have put it one more line plt.subplot and inside this I am putting 3 parameters. Okay, now I'll put my another code. Again subplot 2 means I want to create 2 plots and this in place of 1 I'll put. I want column wise and here 1 represent first plot and this 2 represent second plot. Okay, so second plot would be in front of this in the second column. Second plot would be in the second column. And I can create 3 plots also. Same thing I'll copy and I'll create third plot. So if I want to create 3 plots, first parameter I'm changing to 3. In place of 2, I want to create 3 plots. So this first parameter I'm changing to 3. And this second parameter represents to column. So I want column wise. And this third parameter represent first graph, second graph, and then I have to put here third graph. Let me run this. 3 plots. In a single column, in a single row, we are having 2 plots. Now, in a single row, we are going to put 3 plots. So, 3 columns. First is number of row. If I am putting here 1, it means in single row I am putting 1 plot. If I am putting here 2, in a single row I am putting 2 plots. Second parameter, I am talking about the second parameter. If I am putting here 3, it means I want 3 plots in a row. And this third parameter represents which plot you want to put. Okay, so I think this is enough for today. Just after the class, try this documentation. Reference notes is given in description of this YouTube video. Okay, So guys, can you please confirm me in the chat window, are you getting all these things? Like I can summarize the Matplotlib. We have seen different type of plots in the Matplotlib. Why we needed the Matplotlib? This is good for the visualization. And we have created histograms, scatter plot, bar chart and pie charts. And we also created the multiple plots. Okay. And even I have shown you one 3D plot also in Matplotlib. Okay, so just hit the like button. Lots of people are attending and only some are hitting the like button. You can hit the like button. Okay guys, so I think this is enough for today, and enjoy weekend. There is no class on Saturday, Sunday, and we are going to meet on Monday. And I'll put one assignment on the Matplotlib. Complete your 1 to 5 assignments that are already available. You can see the assignments. Okay, we are having 5 assignments and one more assignment I'll put today based on Matplotlib. So you need to complete these 6 assignments in this weekend, Saturday, Sunday. There is no class today, tomorrow and day after tomorrow. Okay. Missing values we will cover in the next upcoming class. Okay. So thank you so much guys, and we'll meet you on tomorrow, on Monday.